Good afternoon and welcome to the webinar. Today we'll be talking about the foundations of platform engineering and the benefits it can bring your organization. I'm Kim Johnson with the CDW Solutions and Services Marketing Team. And before we get started, I just wanted to mention a few quick housekeeping items. We will save time for Q&A at the end. So if you have questions, please drop those in the chat throughout the presentation and we'll talk through them at the end. And after the webinar, you will be prompted to complete a short survey, which we would really appreciate. If you do that, it's going to open automatically in your browser, and it's just a few quick questions if you wouldn't mind. And now I'll pass the reins to our host, Roger Haney, Chief Architect in the Office of the CTO at CDW. Take it away, Roger.
Thanks, Kim. Welcome, everybody. Want to spend a little bit of time talking about what platform engineering is so that everybody sort of is on the same sheet of music. I noticed several people have platform engineering titles already, so you probably know a lot of this, but just want to make sure everybody is on the same sheet of music. So of course we have to start with a Gartner slide. You have to start every presentation with a Gartner slide. It's the law. And basically they're saying 80% organizations will be having a platform engineering team by next year. So this is an interesting statistic. A lot of Gartner statistics are close, but basically what they're saying is organizations have learned a lot of lessons from the DevOps history and are bringing it into a productized platform as their go-forward strategy. So this is a very important part. We try to treat infrastructure and operations as a product, and there are quite a few things we can gain a benefit of if we do this. So I like to talk about how did we get here. So in the bad old days, when I was growing up, the developers would write and test their code in a vacuum and throw it over the wall at 4 o'clock on a Friday afternoon for our operations team to deploy. On good days, we were done by midnight. On bad days, 2 weeks later, we'd finally get the software running. But we always got the same excuse. It ran on my it ran on my laptop. It ran when I tested it. So we went into DevOps, and what DevOps said is, okay, if you develop the software, you help operationalize the software, you write it, you run it, was one of the popular things. What happened, though, and we'll talk through several of the drawbacks of the DevOps history, is we weren't spending enough time deving anymore. We were spending our dev teams were spending most of their time opsing. We also tried to add security in for DevSecOps. That was a good move because it sort of was the first step towards platform engineering and sort of standardization of processes. But this productization, I think, is a key component of it. So what we try to do in platform engineering is we're going to build a set of tools that really allow us to do self-service. So for a quick mental image, think about AWS. You swipe the credit card, you get a virtual machine, you define a few things, and it goes out and builds it for you. Then you push your code out to it, and you've got a running application. So a lot of customers early on said, well, why can't we do this on-prem or using a single pipeline for AWS and on-prem and Azure and GCP? And this is all the foundations of platform engineering. How do we bring this together to a workflow that allows us to deploy anywhere, manage this application? And so this internal developer platform is sort of being created. It's not really very different than our traditional DevOps Git and CI/CD pipelines, but I would say it's more standardized. And by being more standardized, it allows us to do more automation and move from the traditional CD, continuous development, finally getting to the CD, continuous deployment, where that deployment becomes automated from the production lifecycle. By putting a product owner in it, what we really want to do is treat this as if we were selling it to our internal developers. But we also recognize that we have different constituencies. So we also need to be selling this to our occasional users. We need to be selling this to people who use commercial off-the-shelf software. We need to be selling it to our own infrastructure teams that produce infrastructure as code. So our pipeline has to be a product that encompasses all of that and puts it through this pipeline. It also needs to have a quick feedback loop so that we know what we're working on, we're focused on it, and we're not distracted by a lot of one-offs. So that's the other thing, is sort of making those product decisions and product trade-offs. You'll hear me talk about that through the presentation. So what we want to do is we want to take this product owner, and this person is creating this platform. This pipeline has to serve all of your constituents, and it has to be focused, and it has to have an ongoing development life cycle. We do recognize that your IDP will be a mixture of tools, so it's not one size fits all, but it all works to that common strategy. And I think that's sort of the key piece here, is this product has to develop for all its constituents, no matter where it's going to be deployed. It has to take all of that into account, but it needs to do, as a product owner, it needs to do the biggest bang things first. The other thing it needs to do is it needs to understand the political ramifications of the system, which teams are doing what, which applications are, real revenue drivers, what the risks are per application, those types of things. So we can build a lot of this in. That product owner also has to bring in security. It has to make sure operations is at the table. It has to make sure that we can do all this, operate it, monitor it, maintain it, all of that, while at the same time trying to focus on user self-service. So it's a big job being the product owner. But if you think about it, it's nothing that can't be done. We've done it at all the major cloud providers. I would argue, like VMware is creating their own cloud IDP sort of capabilities as well. I think one of the key points, though, is trying to get to this common API, because when we get to a common API, no matter what type of workload it is, no matter where it should end up, it should just be able to call this API, and on the backside of this API, we can then translate to the specific REST calls to establish this workflow. So as we create that, we also need to be thinking about how we operationalize this. So we've taken to calling it an operational deployment platform. So your IDP connects to your ODP then, and it actually deploys these workloads. And so this is one of the things that this product focus of platform engineering gives us, is to move from what we used to have, where our pipelines would create the software, all the way through to where our pipelines can now deploy the software in a secure and monitored manner, giving us that feedback loop, and attached to the front end for self-service items as well for our more occasional users or COTS users type thing. So we have to bring this all together into one common platform. So here's your little Lego block diagram where we consider the user personas on the left. Again, we're trying to take all of our major constituencies in. We're trying to build out that internal developer platform with our Git repos, our CI, continuous integration, but really focusing on the continuous deployment aspects, which attach to the orchestration and automation components through the API. And this means we can run any type of workload in any different place, whether that's private cloud on-prem, edge workloads we're seeing a lot of as we roll a bunch of this out. Doesn't matter if it's a VM, container, AI, and it's monitored and it's secured. So we have to consider all of this as we're building out our platform as a product. So how do you think about this? So one of the things I like to use when I think about how we're going to build this out for customers is thinking about it like a restaurant. So any given day, you can make whatever meal you want to make, but all of the requirements fall on you. And so it's a one-off sort of thing. So you have to decide what you're going to eat. You have to find a recipe. You have to get your ingredient list. You have to go to the store, buy those ingredients. You have to bring them home, wash them, cut them up, prep them. Then you have to cook them. Then you finally can eat your meal, but then you have to wash the dishes and wash up all your pots and pans and store any leftovers and eventually throw them out a couple days later when you don't finish them. But some days, isn't it a lot easier and a lot less hassle, even if we have to live with certain limitations, to just go to a restaurant? So what we're doing in the restaurant is we're actually sitting down before the restaurant ever opens, and we're defining what it is we're going to offer. And then we work through our automation routines in our kitchen, which would equate to our deployment platform. And then we make sure I can offer a meal that we go out and build the recipe. We go out and buy the materials and make sure we have enough on hand, and we prep them. And then when they're ordered, we cook them and we clean the dishes up and all that. So all of that can be your deployment platform, but it's defined using meals, right, on a menu. So here's your menu of choices. You can order these meals. Now the meals aren't set in stone. You can have what I like to call the the steak options, medium well, rare, these types of things. Those usually equate to what we call t-shirt sizes, small, medium, large. You can have variability built in. You can even design things, and I would say, try to tackle this later, that are more like pizzas. So you have 20 toppings. You can add these toppings in, and we can write automation and orchestration routines for all those different toppings. But you don't get whatever that 21st topping is. We only are allowed to build out what we have time to work on as a product and what is required by our customers and bubble to the top as a product requirement that then, again, if you're thinking as a restaurant, would go into the menu. So what makes this all work then is that waiter. The waiter comes out, takes care of the customer, interfaces with the kitchen. And in our platform engineering, that's usually where we write the API layers. So we generally write a simple thing. We go out, we write our, we have our code, we write our CI routine, we run through test, and then we build our artifact. And then if we're doing this API correctly, that's what enables deployment. And it enables deployment based on tags and versioning and those types of things to wherever the business needs it to run. So that API layer is very important. Start that small, grow it up as we go, but it eventually allows us to have a very detailed menu, as many things as we can offer that are required by our product team. And then we can build those into the pipeline. We can make sure they're secured, make sure they're monitored, and importantly, build that feedback loop. So that's one way I like to think about it, is using this restaurant analogy. So through here, I've thrown in a couple of customer examples on this. One of them, we had a customer that said, okay, we really need to sort of harness, I call it enterpriseify our existing science experiments in our pipeline. So we went out to them, we looked at their people, we looked at their processes, we discovered all the different groups, figured out what technologies they were using. We did a little tool trimming here and there where the different teams were willing maybe to make a change to a more common tool. But we actually went in there and built out different tools, integrated the different tools from different teams, created one code repository, created one common pipeline that allows us to call different tools, but still allows us to have a single pipeline. took their technology, worked it together, began their API build out. That's still in progress, but we decided to go ahead and move some of it to production. 20% at first, then we can build the next 20%. Because that's what their product team decided they needed us to do. So we went in there, helped them build out the tooling, helped them write some code, especially in the CI/CD portion of it, to help get them to specifically rolling out to deployment of code in an automated fashion. So just one example of how we worked with the customer. So if we look at this pipeline and we think about it again as a product, we're still using all the things we learned, the processes and tooling we learned from DevOps. It's still DevOps, except it's sort of DevOps standardized is the way I would sort of to say it. What we do there is, as we go in, we'll find that there are a bunch of different teams and they're doing things in different manners. And they're doing them by organizational boundaries. So this is common in a lot of larger customers that things, little seed projects, I call them science experiments, started up, and they've grown to where they have a sort of life of their own, if you will, some sort of mass moving forward. And what we want to do is not break these tools, but what we need to do is sort of standardize some of this, because without that standardization, it makes it really hard to automate, properly monitor, and properly secure these, which are part of that ops side of the equation. While true DevOps, we do have customers that have their product team has kept people separate. And a lot of times it's around like mainframe automation remains separate. They're not willing to come in yet. Yes, maybe next year we can work towards the common standard, but you may have to develop some additional interfaces for your pipeline to work with them. That's fine. We can set them aside for now. We can leave the organizational boundaries up. Just know that the longer that runs and the more development, the more tech debt you're going to have, the harder it may be to integrate. But politically, we know if we're going to make this happen, we have to do it. We have to get some success. We have to get some people buy-in so that we can grow the common pipeline, and then they'll see the benefits of joining in and they'll become much more willing to break some of those silos down. So we see this a lot. We work with a lot of different teams. We sort of prioritize who we're going to bring on, and then we work towards bringing each one of these silos into a common pipeline. So you don't have to bite it all off at once. The reason we do this is because quite often in DevOps, a silo would build things and they would learn how to do things and they would develop things and they would do them differently. So the ops team for product A here doesn't work on the release, but product B made that a portion of the ops team's responsibility. Well, in doing so now, we don't have a standard release methodology. And since we don't have a standard release methodology, we get stuck at the continuous development portion, and we can't get into the automated deployment portion. So this just kind of shows one of the faulty things we had in DevOps is we allow people to do this. We want people to develop automation. We enjoy people pushing their workloads in an automated fashion, but we didn't have the standardization that allow us to go back and create this self-service product that we're trying to approach with platform engineering. Another problem we have, and I have a huge security team that works with us on the pipelines, and they keep saying, well, where? Which pipeline? There's no standardized set of tooling for them to apply overall security at. So then they spend longer in the review cycle, or they have to do manual steps. So one of the big things we are trying to achieve in platform engineering is really bringing that DevSecOps approach in, but giving it a standardized thing. So if we take our menu in our platform engineering restaurant, and we have a standard printed menu and people live to that menu, then the security team can look at that menu and they can appropriately plug in. They can work on config management. They can work on change management. They can work on code smells. You know, is every everything in the bill of materials up to date, or is there a bug report out on one of these that needs to be fixed? You know, they should be driving some of the patching and updating information so that they can meet their security audit, they can meet their risk audit, they can do appropriate governance. So bringing them in and making sure our product owner knows that running software has to be secure, has to be monitored, or it's not a viable product. They have to bring that into the product requirements as well. So really bringing in a lot of these other users. And when we do this appropriately, my security team, they apply the appropriate tools. And I've got a slide that shows a lot of how we approach that. But what you'll notice is every set of tools actually corresponds to a step in the pipeline and how they can help us reduce risk up front, so that when it's deployed, it doesn't deploy, then go to security for a 7-day review before it actually gets customers on it. So if we look at DevOps, we started to bring together development and operations. We started to break some of the silos down, and our goal was to enable faster, reliable software delivery. With platform engineering, we're trying to keep all that, except we're trying to more or less standardize the approach. So the different DevOps teams are all working in a common pipeline. And this common pipeline can now be, we can add self-service to it. We can add additional user types into it. Then we can do more automation. Then we can do more ability to run different workloads in different places and add that security in, add that monitoring back in. And this actually frees the developer up to do less of the operations, do more of the development, because now they're developing to a standard instead of just developing to get their code there and then trying to get it to run. They know if they develop to the standard, it'll run, right? Just like you think about something like AWS or GCP or Azure. You develop it to their standard, you push it out, and it runs. We're trying to do the same thing, except we're doing it in a hybrid cloud fashion. So when I pitch this to a lot of development teams, they're like, yes, okay, give us the standard, we'll write to it if you promise that it'll run and I don't have to worry as much about the operations, right? I still have to think about, does it pass security? Does it pass, do I include the monitoring? All those components, but I no longer really have to worry about the operations. Just like ordering off the menu, I'm going to get, I know what a medium rare steak is like, I'm going to get that. I know what my French fries are like or whatever. I'm going to get those products that you're describing here in an automated fashion. So when we look at this, yes, we still have different product teams. The product teams are still going to be somewhat free to develop their code in the way they need to develop their code. But what we add in usually is this site reliability engineering or SRE role. And that SRE translates with that product team into the appropriate tooling based on the product that we're building for them, the platform engineering product that we're building for them. Helps their product, ABC, fit into the platform so that then we can automate, deploy, secure, and monitor it, and continue to operate it in an enterprise fashion. So that's sort of the difference. We still give the developer a lot of freedom to develop, because we don't want them to be stifled and not be creative, right? That's why we've hired them to build out the best products so our customers can use them or our internal teams can use them. But we do want to help translate that to the standard platform so that we can add to this virtuous cycle of automation, self-service, securely monitored and operated applications. We do also tell our platform teams that they sort of need to be, I guess, adopt the servant leadership mindset. Think about you're enabling other teams. I'm enabling my developers to develop, even though I'm putting some guardrails around them. If I teach them the guardrails and they learn to live within the guardrails, then it's smooth, and smooth is fast, right? So you have to sort of apply some of those servant leadership attitudes towards building out your platform as well. So what's the reality? You know, our development teams are writing applications that our business runs on. And that's true whether or not it's a team running commercial off-the-shelf software. That really doesn't matter. That's just considered another development team to us because we do run a lot of COTS applications and our business does run on them. So we do have to include them as developer teams, if you will. We want to enable them. We want to give them as much self-service as we can. We do know that we can't be completely prescriptive. Some need a small something, some need a really large one. We want to think about including cost when we do this, whether or not we charge back or show back. The concept of including the cost on it is actually a really good way to understand that product ownership piece of it. You know, what is the value of doing this, whether or not it's a true cost or not? You know, a lot of people in DevOps use story points or things like that to build out their backlogs. They're being product owners to know what to work on in their software. They do get that we extend that into the platform to say, you know, what is the cost benefit analysis, if you will, of me turning this into self-service? How much of your time do I save? How much cost of that do I save by enabling the developer experience and self-service? You know, what you also have to apply then, what is the value of forcing you into the box versus extending the box to support the way you do things today? And those are some tough conversations to have with development teams who, you know, don't want to have to change, but sometimes the right answer is you need to join the product. You got to give in this space because that allows us to get you there faster, to get you there smoother, to give you a better experience. So we do have to have some of those hard conversations with the development teams to get to a platform to support them. Bringing in security, we try to create a security working group. This gets all the security people talking about security. And then they bring somebody to the platform team. One of the reasons we do this is there's a lot of learning that goes on in the security team. They usually start out with, well, this is the way we've always done it. We don't understand how to do, you know, shift left security. So we'll bring in our security folks to help educate that group. And when they learn, oh, we can cover this up front, then we fit security into our golden path. And that golden path then allows them to make sure that, hey, if it goes through these checks and balances, it is secure, right? So that security working group, we spend a lot of time educating, bringing people along there, and then we bring them into the platform team, or a few of them, leadership-wise, into the platform team to where, you know, we figure out how to include them as we design our product of our platform engineering. Um, our goal is to get to frameworks and APIs. If we can get to frameworks and APIs, we can increase the automation. If we can increase the automation, we can increase security, we can increase self-service, we can increase the different platforms we can deploy to. The developers can feel free to go from a container, can run an AI workload. Really doesn't matter to us because we've built frameworks and APIs that allow them to push their workload directly into production within the guardrails we've set up around monitoring, security, et cetera. So it is a natural evolution of our DevOps practices. It does put some guardrails on, but we're trying to make things smoother, faster, easier to get to back to that self-service to create a better product for all the different teams. I promised to show you a little bit about the security and how we bring that in. If you look at the stages across the top here, they really align to the stages of our pipeline. Whether it's reviewing the code in Git and which different libraries you're using and are they secure, up to date. How do we and integration? How do we get into your tooling, your testing tool mix and run our own tools? Those types of things. As you deploy it, can we use a one-time build? Teaching a lot of teams that if you fail a build test, that you go back and fix it in code, and we just, we don't try to fix it, fix your snowflake. We go back, learn how to do those types of things to where the security team can actually say, yes, this passed all of our tooling and it is secure, and we don't have any out of tree processes, or if we do, then the security team is just working on exceptions and they can get those turned around a lot faster. So we do try to build a lot of this in because this is what gets us really to automated deployment self-service, right? Which actually makes our developers faster and happier. So what does it all look like? Well, it's still CI, and here we have the small d for continuous development, and then the big D is continuous deployment. We're still trying to get to that stage, but what we realized is instead of having a bunch of different teams doing it differently, if we standardize on a single platform, we take a product focus at it, we actually speed that up. So it's really just trying to get to that last bullet, right? Yes, we go in, we're trying to operate it, secure it, monitor it, etc. But all of that allows us to actually make it easier on the developer self-service and create portals for them. So quite often we go back and say, okay, do you want to do this via pipeline, or are you interested in like a ServiceNow ticket for the occasional user? Doesn't really matter. We can hook all those together into the pipeline, still supply our security, still supply our monitoring, making sure that the application's performant and available, those types of things, and then pipeline and automate the whole thing. So that's what we're trying to get to. It's an evolution more than a replacement of our DevOps principles. So another example, worked with a large American telco. They roll out things to all the base stations in every cell tower. So worked with them on that. They were spending a lot of time. They had a lot of manual steps. Really just worked with them to increase the throughput of their CI/CD pipelines and really getting to that CD deployment piece of it in an automated fashion. Again, a lot of it is building guardrails into their test and build processes. Did have some, various teams that weren't too happy. They were being pushed into a guardrailed system. But when they saw that, oh, if I live within these rules, the rest of this occurs automatically. No more late nights and weekends. I can trust the system to deploy it for me during the day. Then everybody was happy. We did use, Terraform Cloud, GitLab. We used a tool called Spectral Cloud, which is a platform as a service or a software as a service Kubernetes platform. It was offering us the ability to do multi-cloud as well as on-prem VMware and AHV type VM deployments. And that really helped us quickly get to all the different types of end systems that they were trying to deploy to. All right, let's talk a little bit about the operations side. So we talked about the standardization of the pipeline. Part of what we're trying to get here is get to that sort of API layer, because if we can get to that API layer, we can take a piece on the back end and we can swap out tools. So a lot of customers trying to get off VMware because the price went up, or trying to figure out what their stance is. I've got people doing all sorts of different moves there. But if we've API'd this appropriately, I can swap out the VMware Terraform provider for the Nutanix Terraform provider, or for a Kubernetes provider that allows us to run containers if we move a VM into a container, or spin up an AI workload, those types of things. But those APIs allow us to apply our security, our monitoring tools, control our identity, which is important for our security teams. And they really don't care what we're going to deploy to, whether we've built a private cloud on-prem, we're using public clouds, or public cloud on-prem sorts of things. A lot of edge now. We also work with a lot of manufacturing and retail customers and healthcare, doing a whole lot of edge deployments. Doesn't really matter. It's the same call from the orchestration and automation pieces. We just translate it there at the API layer. So one of the things that makes this possible is the feedback loop of observability. So I've harped on this almost on every slide about the monitoring aspects. And what we try to do is we try to put together the monitoring. To get to self-service, we need to both monitor the application. Is it performant? Is it available? All of the things that the application teams worry about. And at the same time, bring in the underlying operations-focused monitoring tools and bring it together so that we're seeing both sides. Yeah, I can fail performance or availability metrics on 10 different applications, but if I've lost a switch and I need to switch my DNS away from this region or this AZ, then I know that because I'm monitoring the operations side of the house as well. And then I can actually switch my applications where they're running away so that they become available again. So the full stack of integrated visibility, observability is a very key important part of this, equally to the security, because it enables that automation piece. It enables your uptime. It enables things like moving active from active passive or a warm standby solution. Another thing that we're seeing a lot of people take interest in, and I'm just going to introduce a few slides here because I didn't want to talk about the next customer and what we're doing until I made sure everybody understood how our approach worked. So this customer has a container first strategy. They know in the next 5 years they want to be specifically container first. They're almost to 50% containerized applications today. So they said, all right, let's renew VMware one more time, but let's look at the ways to do this that maybe go in a container first way. So what we've done with them is we've worked on using the KubeVirt capabilities. We actually run the virtual machines under the control of their container platform. And the way this works is we simply spin up another container, and in that container, since it thinks its own, a container just thinks it's its own Linux server, then what we do is we then run the hypervisor, and inside that hypervisor, we can either run like a different version of Linux, or we can run a Windows workload. Doesn't really matter. And what we're doing is passing calls down into the OS kernel. So what this allows us to do is to take our, traditionally we run our Kubernetes in virtual machines, but we're now running the Kubernetes on bare metal. And then we can run the virtual machine inside of our Kubernetes. So what does this give us? This gives us one unified networking plane where we can control our routing, switching, our ingress gateways, layer 4 and 7 firewalling, one place to do DNS, one place to do load balancing and IPAM for both our containers and VMs. We gain the capabilities of Kubernetes, the namespacing, separation of workloads. We allow Kubernetes to move the virtual machine around similarly to the way you do it today, say in VMware. It does the same sort of thing. It actually has a pod that watches the virtual machine, and if the virtual machine becomes non-responsive, it moves it to another host and spins it back up or restarts another virtual machine so that it stays up and running. And we work a lot with the storage aspects, file block, object storage. We make that all available to the virtual machine, and that way if the virtual machine has to move to another host, it can still get to all of its file systems. It uses the Kubernetes persistent volumes, which are really just like you do a VMDK file today. So it's a file-based block storage device for a virtual machine or a container. So what we've done for that customer is really take their virtual machines. We're moving 3,600 VMs over to this system. They'll slowly be whittling those down. In fact, I think they're probably going to take about 1,000 of them right off the bat and say, don't move these. We're just going to recreate them as containers because they're on kind of a low-hanging fruit portion of it. So we don't have to move them. They did move all their VDI out to Azure. That was one of the decisions they made, so we're helping them do that. They store their code in GitLab. We're helping them write Terraform and Ansible. We're automating the movement of the virtual machines. And then we're using an on-prem to cloud disaster recovery. So when we snapshot these VM disks and all the corresponding information in the config maps and the secrets and those types of things you get with Kubernetes, we wrap that into a package and snap it up to the cloud. So if they need to recreate it, they just reboot it up in the cloud. So what we've done is we've based this on Red Hat OpenShift. We run the OpenShift on-prem on bare metal, as well as we have OpenShift up on AWS and OpenShift up in Azure, which are their clouds. As they do this, they're really looking at their message buses and how they do their big databases and trying to create more PaaS services and actually going back to bare metal databases in some instances where that was the only thing running on a virtual machine. So quite a lot of fun in helping them through this journey. Something that allows us to do this on-prem very much more cloud-like is our vendors are really coming along. They've realized that they really have to be a private cloud and think about that, and really have to be a good citizen in a hybrid cloud. So they've gone from the way they used to do things. Every device had its own GUI, and very few had APIs, to where they started working together into predefined solutions. Then they went into a software-defined methodology, and now they're really helping us get to a hybrid cloud with not everything has to be on their GUI. They can play a lot better with common tooling, and therefore they can plug into our platform engineering pipeline a whole lot easier. So we take this approach. We approach it for security and standardization, but it really helps our developers come out and say, you know, I have an application. If you need to run this in a PCI enclave on-prem because that's what your PCI 4 audit requires, that's fine. I don't care as a developer where it runs necessarily. We can work on that for them through the pipeline to call the right API, to put it in the right place and make it run, make sure it's secured, make sure it meets our compliance requirements. So these are the kinds of things we work with customers on all day long to help them get to this point. So Promise to leave time for questions. So Kim, I'm going to kick it back to you. Hopefully you've been watching the chat for me. Do you
Yes,
have any questions for
we have
us?
two. Yes, and reminder to everybody, we still have time. If you have questions, please drop them in the chat and get them queued up. Okay, Roger, the first question is, this seems like a lot of work all at once. Do I have to do it all at the same time?
Okay, so real easy answer to that. No, nobody's going to do this all at once. Um, we like to come in and figure out what our end state vision is. And then like any good product, you want to figure out what features are going to give us the best bang for the buck the fastest, meet as many requirements as possible. So different customers focus different things. They also know politically which teams are more likely to come on board. So all of this goes into it. But no, we do one feature at a time. We break things down. We say, okay, we're going to work on this. Maybe we're working, with the security team to work on some shift left security, but at the same time, we're working with this group over here to build out Terraform scripting. And a lot of this, is really about figuring out what our payback is. I would say this isn't a never-ending journey. Hopefully we do get to this promised nirvana, but it is one step at a time. It doesn't have to be swallowed all at once. Anything you do should be working towards your strategy. That's a best practice. But realize that not everything is actually even going to go there, but you understand that this is going to be worth the technical debt for us to have to do it maybe later. But those are the decisions you make, your product ownership team makes. And as they create this pipeline, we take one step at a time to give us the best bang for the buck that we could do.
Okay.
You had another question?
Yeah, the next question is, can you comment on the inclusion of FinOps, i.e. DevSec FinOps?
Yes, so I briefly touched on the cost aspect and trying to drive that into our decision making. And FinOps is part of it. I spend a lot of time, I have some consultants that okay, you spent so much on this hardware and this and this. We try to come up with what is a CPU core worth? And so then we can compare this, this is an 8-core CPU workload. What does it cost to run in this data center, in this colo, at AWS or at Azure? And the business can then make the decision knowing those costs. You'd be surprised at how comfortable they get with that really quickly to say, oh, I never knew what it cost me. Now I can make a good cost-based decision. Whereas before, hey, everything was free, IT paid for it. So we really work FinOps into all of our things. We don't create an actual, hundredths of a cent per second sort of thing. We try to get it, pretty close. We adjust it regularly, but it is that decision-making point that really drives the product aspect, but it also drives, where things get deployed. So a business may decide, hey, this is a web front end that I need in every geography. Great, that sounds like a perfect application for a CDN-based multi-cloud or at least multi-region, multi-AZ deployment in the public cloud. You may say, no, I need to run this for PCI 4 requirements in this enclave here. No, it's going to cost you more per minute to do so. But hey, that's a business decision that can be made and discussed because we give them visibility. So FinOps is really about providing that visibility. Without that visibility, they also just like to leave it out there running. We've seen folks that, okay, I need to leave the last 5 versions of my code running in all the different data centers and public clouds because, I don't know when I'm going to have to roll back. Okay, that's great, but it's not really true. You're just doing that because you've never seen what it actually costs you to do that. oh, funny, you show them the cost and suddenly, oh, we're just going to leave the last two up and running, or last one up and running, and a second one in cold standby before we delete the project for that version. And it's because they haven't seen a lot of the data. They don't know. If they don't know, it costs them nothing, right? So I have this conversation with a lot of folks, and we build that into the pipeline. There's a cost benefit analysis for where you're going to run it. Should be part of the business decision about which tag you throw on where you want this deployed. So yes, it's very much a part of the product orientation of your platform that you develop. So hopefully I answered that one.
And we have one last question. I'm not sure my staff have the correct skills to do this work. How do I upskill them?
Yes, agreed. So your developers usually have the skills because we're taking what they've spent years and years learning, and we're trying to bring it along to our security teams, to our operations teams, add it into monitoring, and add it, create automation. These are all new skill sets for a lot of folks. We do generally have people who are on the teams who are becoming familiar with this. They can be our change leaders. But a lot of this is sitting down and doing it. So when we work with customers, we'll start off, we may code up a solution for them. So to show them, hey, this can be done. This is how it's done. Let's go into your lab and create an MVP in the lab. And what we'll do is show you that there's not a lot of coding in a lot of this for the operations side. There's not a lot of custom code written. It's really just manipulating key value pairs. And it's the same key value pairs that you put in the GUI. We're just gathering them up all at once, and then we're just going to push them all at once. So we sit down with folks and we bring them along, and working together, we bring them these skills. And it's I have my child. We started this 2 years ago with a large bank, taught them how to do Terraform deployment of infrastructure for firewalling and for load balancing and for identity. And really, a couple people took to it, and they've run off and built out their own projects, and they're now deploying in different parts without us. And that's great. Other people are seeing that happen, so they jump into the projects we're working on so they can go through that skill building piece as well. I would say a large part of it is, setting proper goals for skills development, but giving them the ability to work with somebody that has gone through this gives them a lot more comfort that they can do this and they won't push and break everything all at once. And then they get a couple of successful deployments under their belt. I remember we were pushing out a whole new set of firewall rules. We had a change window. In about 5 minutes, we were done, and sat there and watched it for a little while, made sure there were no issues, and then said, okay, 15 minutes, I think we're done, close the change window. And they were like, this used to take 2 hours. So now they're on board, right? Because they see the benefits, they see the value. As you do a lot of the self-service components, people really see the benefit of it. They get on board really quickly. But it does take having a mentor for it, somebody that, it's like learning a new language. You're scared to speak it until somebody makes you, and then you sit down. If you've got a friendly person to chat with, you learn a lot faster that language. It's the same with all of these skills that we're introducing to the teams. So again,
We actually did get another one if you want to try to fit one more in real quick.
One more quick statement on that. It's actually part of why we also do things in bite-sized pieces. So we're not like the first question you asked, we're not trying to do it all at once, because we know we're developing skills along the way. We know we're starting to break down some of the silos along the way. We're trying to interest people in and getting on board, and that takes time to develop that, priming the pump, as we call it, getting all that done. So all of this feeds into an accelerating pipeline build, but it doesn't start that way. Okay, sorry, that was the last thing I want to say on that. Yes, we have 5 minutes. I can do another question.
Okay, and this one's about the potential impact of AI on broad platform processes.
Yeah, so I would say that if you platform engineer correctly, you increase the ability to use AI tooling in a couple of ways. One, on the monitoring piece, again, when you see what's down, you can apply the appropriate automated response. This can be assisted with AI. So in a lot of the places we're rolling out a bunch of Kubernetes now, there are tooling that read through the state of everything. And if there's a problem, a consistent problem that the automation routines don't do, we kick that out to an AI bot that's been trained on all the Kubernetes documentation and fine-tuned, and it gives us the 5 things that it would try, right? So I can now take a lower level person and have them troubleshoot a whole lot faster. So just a simple example, as we build this in, when you build that automation loop in, you build a point of attaching AI and allowing a lot of AI to run. Under DevOps, if everything was done differently, it'd be much harder to attach AI to the operational ability, the self-service components of the system. So if we do our platform correctly, it actually enables us better integration points with AI. We do, the developers have started using a lot of AI tools for code reviews. I have AI write me little applications now that I use for demos and things like that. They don't always get it right, but they get me 80% of the way there pretty quickly. It really helps in documenting things. So, used correctly, you can start plugging AI in initially. But the other thing I have to say is really, if you want to enable AI, build a good platform, because the platform standardization piece, the productization of it, really allows you to apply the AI where it'll be much more powerful and much more capable for what you're trying to get done.
Awesome. Well, thank you, Roger, for your time, and thank you for everybody that joined us today. We really appreciate your time as well. As mentioned in the very beginning, once we end the webinar, a short survey will pop up in your browser. You can indicate on that survey if you'd like to receive a copy of the presentation or the recording from today's webinar, or if you have any other questions or comments for us, we would be happy to help. Thank you again for your time, and have a great day.